How you guys doing? You're on camera. Oh wow. Um, so today is my third and final lesson. I will be, probably leaving sometime. I know. I have been disappointed about it actually. Um, first you want to grab these guys. Maybe. I'm not sure. Probably not going to quite get there, but we'll find out. So we're going to start out the day by going outside, and you guys are going to grab your cover boards, take one last picture if you can. Nice. Thank you very much. All right. Lock in with me. Anyone? Everyone? So you're going to go outside, take another picture of your cover boards, bring them back in, put them in that green box right there, and then you're going to see two water samples, which are from two different environments. And if you would not shake around the one that is pretty murky, that'd be good, because then everyone will get to see through it a little bit more clearly. Or you can pick the other one and look at it, just don't drop it. And I would like you to consider this question, or basically, talk about what you see in the two samples and make a list in your interactive notebooks that describes biodiversity. And this is going to be a somewhat of a continual list throughout this lesson. So, leave it open-ended. And, today's unit is on biodiversity. So, let's go outside, and then we'll get back to it. Hey, don't do this. Come on.
I'll hold down the fort again.
No, that's good.
Don't forget to collect an organism if you find one. Leave one. I will keep your cover for it. Right? I know. That's okay. It's breezy. And then after that, let's see. Oh, there's a bug in there. Yes, there is. Look at it. Pretty nasty. It's so kind of. I don't know what it is, but I don't like it.
up the jars. Good. Okay. Alright, I don't hear any notes on biodiversity. What do you guys got? How these kind of enclosed systems begin. Yeah, maybe how they came up in the building system, how they came up biodiversity. I'm kind of leaning into something, but it can just keep about that. Nice. Well, I missed it. My back was to yours, so yes. There's quite a few. Some of them are really small. You guys have salt, a bug, huh? Do you see a worm by chance? No? There is a worm. It's pretty hard to see. Yes, thank you. There's trash in there. In the other one. Yeah, there's another one right there.
Are they swimming?
What? So we're kind of like thinking about the components that make up this ecosystem and create biodiversity. I'm just throwing that out. We're thinking about the components that make up that mini ecosystem and create the biodiversity. So basically exactly what I said. But
So like, this is all we have to do to think of it?
I think so. Definitely. Boy, money, water, one, two. Well, actually, I just found it with the samples. I mean, it was kind of like trash slash pollution.
I literally have a broken ankle, so I'm gonna have to like actually do that and
Okay.
I didn't. Cedric's pretty good.
How?
Number one. I feel so bad. That's what I'm talking about. And he was replying to me, but I didn't want to. There you go. Now we know. I didn't know it started. Was it my fault? Did it cost? He's like, I know. Like, I got into
Oh,
so then like 6 hours later, he goes, sorry.
all right. So can I get your attention? And can I hear what you guys came up with? Yes.
I found,
From sample A.
wait, is that the one?
The clear one, yep.
Never mind, I found someone to do.
Yeah.
Okay. I wrote, obviously it's clear, but like, what would you say the, like, weeds
Yeah, weeds. Perfect.
and then bugs
Yep.
and I guess a worm?
Okay. Weeds, bugs, a worm. No one said water, but that
I
was
have that.
possibly assumed. Thank you very much. We have some pollution in there in the one, the candy wrapper, and I think the plastic button or whatever, chutney, whatever you want to call it. So these two samples, one came from the pond by the high school, or not by the high school, by the middle school, and the other one came from a pond up in Binoculars Canyon. And you can probably guess that the dirty one was from the pond, and the clear one is from up in Binoculars Canyon. And yeah, so now I'm going to show you guys a video on biodiversity, and I think we'll leave that there and see what it looks like. And I would like you to kind of look at these. We're still thinking about these components, what makes up biodiversity, but this video is kind of going to separate them a little bit more into categories. And if you get that down, and yeah, just pay attention, I think we'll be set. You guys can do that really well, huh? My professor's definitely going to say, check yourself. All right. You may have to restart. All right. And go.
Our planet's diverse, thriving ecosystems may seem like permanent fixtures, but they're actually vulnerable to collapse. Jungles can become deserts, and reefs can become lifeless rocks, even without cataclysmic events like volcanoes and asteroids. What makes one ecosystem strong and another weak in the face of change? The answer, to a large extent, is biodiversity. Biodiversity is built out of three intertwined features: ecosystem diversity, species diversity, and genetic diversity. The more intertwining there is between these features, the denser and more resilient the weed becomes. the net disintegrate. So, what if we were to remove one species from the rainforest? Would the system fall apart? Probably not. The volume of species, the genetic diversity, and the complexity of the ecosystems form such rich biodiversity in this forest that one species gap in the lead won't cause it to unravel. The forest can stay resilient and recover from change. But that's not true in every case. In some environments, taking away just one important component can undermine the entire system. Take coral reefs, for instance. Many organisms in a reef are dependent on the coral. It provides key microhabitats, shelter, and breeding grounds for thousands of species of fish, crustaceans, and mollusks. Corals also form interdependent relationships with fungi and bacteria. The coral itself is a loom that allows the tangled net of biodiversity to be woven. That makes coral a keystone organism, one that many others depend on for their survival. So what happens when destructive fishing practices, pollution, and ocean acidification weaken coral or even kill it altogether? Exactly what you might think. The loss of this keystone species leaves its dependents at a loss too, threatening the entire fabric of the reef. Ecosystem, species, and genetic diversity together form the complex tangled weave of biodiversity that is vital for the survival of organisms on Earth. We humans are woven into this biodiversity too. When just a few strands are lost, our own well-being is threatened. Cut too many links, and we risk unraveling it all. What the future brings is unpredictable, but biodiversity can give us an insurance policy, Earth's own safety net, to safeguard our survival.
Okay. So, now I get to clean it up. What do we have now? As far as, sorry about that, our list goes. Not much? What could that one other one be? Yes. Who said that? Very good. So, can we come up with a definition of biodiversity now? I think we can. I'll give you guys 1 minute to come up with a definition in your pods, and then I'm going to call on one group, and I'll give an answer all for it.
Like when the water is blue.
What does bio mean? Bio means life, living, same thing. Diversity means different. I'm going to go with variety just because I like the way it rolls off the tongue, but I think we're 100% right on that. So the variety of life. And if we remember what the video said, it's wow, I have terrible handwriting. You guys laughing at me? Biodiversity, the variety of life at all structural levels. So now we're going to go back to what the video talked about. And what were those structural levels? Yes. Okay. I think you guys are doing this, but if you are putting this in your notebooks, that is a great idea. Be valuable for your test. I guarantee it. So species diversity. I feel like we have a pretty good definition of what biodiversity is. The variety of life at all structural levels, and those levels are ecosystem, genetic, and species diversity. Ecosystem diversity, can we think of any examples of ecosystem diversity? Or the level of ecosystem, yeah, different levels of ecosystem diversity. How about that? Sorry. Yes? Yes, that is very accurate. You think of rainforests, deserts, arid grasslands, all of these different things are ecosystem diversities, or different ecosystems that have diversity within them. And I would argue that you can basically take an ecosystem down to almost the smallest unit that you want to go with it. I know I'm not saying that well, but what I'm trying to say is that we can have an ecosystem in a bottle, we can have a bacterial ecosystem in our stomach, we can have an ecosystem that is actually the entire globe in the biosphere, because ocean currents and winds and everything pushes around the world to create climate and weather, and yeah, so that's kind of the touch that I want to do on that. And genetic diversity is basically here if populations are extremely small, they can be susceptible to disease or death because they don't have the genetic variability to be able to persevere and push through some kind of a sudden climate happening or event. And the one that I really kind of want to focus on, and these two are going to be covered more so in later topics, is species diversity. And I think I chose this because species diversity is it's easier to conceptualize, I would say. And so species diversity, do we know what species richness is, or can we come up with what species richness is? Oh, you're yawning? Go for it. how many in the specific species, or yes? Did you have anything else? No? Okay, can I erase this? Are you guys out of here at 3:07? 3:10. Trailed off a little bit there, huh? Thank you for laughing. So species diversity and species richness are very closely linked, and how many richness is how many species there are in a given environment, including like how many species of plants there are, how many species of animals there are, how many species of fungi, how many species of microbes. All of those things contribute to species richness. So the main question that I want to ask is, why would this species richness contribute to the function of an ecosystem? So in other words, why would the different number of species in an ecosystem contribute to an ecosystem maintaining its stability and not being affected by certain disturbances that happen to occur? Yes.
If there's like just a few of them, and you come into it, like one is like one of the next to a whole thing, or there's like a bunch of them. So you take one away, they won't change as much.
Okay. I think you need to turn the volume up because you're killing it. Let's hear it one more time. Sorry.
So if you have a ecosystem of like just a few species, if you take one away, it'll like mess up the entire ecosystem. But if you have one with like a ton of different species, you take one away, it won't affect it that much. You can still like go on.
Yes. So I think that is almost the perfect answer. Basically exactly what I was looking for. And if we think about an owl, and it has two options, a mouse and a squirrel. If what? Why are you guys laughing at me? Why are you laughing? Those are two R's. Anyway, we have a mouse and a squirrel. In this case, the owl has options, and you can choose whatever he wants to eat. But if we take away the squirrel, then the owl only has a mouse to eat, and then he eats one mouse, he eats two mice, he eats 300 mice, and then the entire population of mice is gone. And the owl is looking around and saying, oh man, I don't have anything to eat anymore. And then the owl dies, and you have a total ecosystem collapse. And I think you said that, all right, give me 1 second if you don't mind. So I think we kind of have answered that question. Just not enough time today. So I think we can come up with something a little bit more general, somewhat cycling of what? Energy. Energy and matter. So, energy and matter. The next point that I want to talk about is if we think about the cycling of energy and matter, an important point to really remember in this food web is that these different players in the ecosystem have different effects, or how would I say that? The strengths of their interactions vary. So, say this is a whale, and this is an eel, and this is a shark. The whale is going to, we're going to call this a primary producer plankton. And the whale is going to take in a ton of energy from this plankton. So this should probably be, I would like this to be drawn to scale, but I'm not doing a great job of getting flight plan going on. So we're just going to say that there's a ton of energy going into the whale, and then what's going to happen, but the whale's going to swim around for 20 years, it's going to come out here, and then one day the whale's going to die. Whale's dead, right? He goes to the bottom of the ocean. Yeah, only for like a day or two. Let's go with that. So the whale goes to the bottom of the ocean, and there's going to be a succession of organisms that basically feed on this whale, first taking all of his skin, and then his blubber, and then his fat, and then the bones, and then everything is going to disappear, and a new ecosystem is going to form down there. What was that? Was that related to biodiversity? So a new ecosystem is going to form down there. You're going to have little fish. Messed it up. Little fish that feed on the whale, who are alive. Sorry. It's fun with this. And this energy is going to cycle back into the system in some way, shape, or form. But if you take away the whale completely, I don't think my diagram is quite big enough. But if I made it bigger, you would see that there are less ways for the energy to cycle through the system. And if that happens, then there will be how do they write on words like this? A significant drop in the ecosystem function. Does that make sense? Kind of, even though it seems convincing. So another way to think about it, I think we have, probably just going to keep on this train really. Think about the internet. There are tons of servers that are there are tons of servers that are pushing information around and sending messages. I mean, that could create you an entire another web. No, they're not serious. They're like but gosh darn it. Like here, 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 here. This is going to be erased, and we're going to put a big player in. Google. Holy cow. Facebook. Whatever you want it to be. So if my computer crashes, it's not really a big deal. Nobody cares. But if Google crashes, it is a big deal, right? So, I don't know. There's, one more thing. So, that is, yeah, that's my spiel on that. The big players are more important, but what we want to come back to is that the more pieces that are in an ecosystem, i.e. biodiversity, like more plant species, more everything that there is, the bigger that this network gets. So it's massive network. And then the lesser the chance that when something bad happens, it's going to significantly disrupt the ecosystem. Other idea. We have a plane. Cockpit. All good. Got windows. You got some bolts here. Yeah, I know, right? That's not what my mom's doing when I was a kid. So we have airplanes. We have engines. Stick with me, stick with me. I know I'm beating this into the ground, but I hope that you're not going to forget it ever again. So we have engines, we have wings, we have a rudder, we have pilots, we have curtains so you can fall asleep, we have lighting, there's air conditioning, and the idea is that, I gotta look at this one more time, sorry. No idea where we're at. The idea is that if we remove the curtain or there's not air conditioning, the plane's probably going to continue to work just fine, right? But if we remove 2 bolts right here that connect this wing to the fuselage, the wing's going to fall off. And this plane, it may circle for a little while, but it's going to circle in a downward spiral, and the plane's going to crash. So that's the same thing. That's the same thing with the ecosystem. Everything in this system is doing something different, and some of them have more important roles than others. But the more bolts you have, the better off you'll be. Boom. Alright, so, yeah, that's, kind of what I've got for you, to be honest. What do you guys think? Maybe? I don't know. We're going to do one more. Just fun. It won't take very long. It's a quiz, actually. Oh my gosh. Computer? Mute. I know. It's going mention that.
I just found it on the ground and he was yelling at us to come in. I just put it back first.
And would you guys mind putting up when you're done with your aha, getting up the stools and the bins for me?
I probably saw me.
Shut up!